Good evening. My name is Ruby Key. For the past few years, I have stayed home caring for my family. But before that, I had multiple job experience in English/Mandarin teaching, production management, and customer service. I joined Savvy Coder's Data Analytics Bootcamp to seek for a new career. During the process, not only I acquired new skills, but I realized that exploring the world with data analytics tools is a perfect fit for my curious nature. I enjoy this path so much that I determined to better myself every day and hopefully to eventually be a data scientist. I have always been interested in global affairs, and I used to track shipping time for my production management job. So when I was looking for capstone ideas, COVID and the global supply chain disruption caught my attention. First, I looked into papers that's published by International Monetary Fund, and then I obtained the data that's the relevant data. After cleaning and reformatting the data with Python pandas, I combined them and put together a visualization utilizing Tableau. Without further ado, here is my capstone. Yeah, I'm a little lost. Which one's my screen? Let's see. Oh, yeah, here it is. Yay. Can you all see my cover page? How COVID lockdown affected global trading and the aftermath. Here, I'll be focused on the lockdown side of COVID infection. These are the papers that I read from International Monetary Fund. Global for economic outlook, supply chain port congestion, and shipping cost inflation. These are very interesting read and has amazing charts. I will highly recommend it. If you're interested, take a look. And I will start from COVID and lockdown and move on to the trading and compare the connection between them, and then move on to shipping costs and shipping time. Finally, I wanted to talk about, did COVID lockdown affected inflation? Finally, I'll bring you my conclusion. Here are the 5 data sets that I worked with. First is the stringency index. These will be an indicator for lockdownness. For 0 to 100, 100 being most strict. And the next thing is trade data. And then is Baltic dry index. This will be a proxy for the shipping cost. Next is purchasing managers index. This is done by giving out survey to big companies that has huge contribution to GDP and ask their new orders, inventory levels, and how they feel about the future. A PMI above 50 is indicating an expansion. Otherwise, less than 50 indicates a contraction. So this PMI here will be a proxy for our shipping time. Last but not least, consumer price index. This is a measure of the average change over time in the prices paid by urban consumers for a market basket of consumer goods and services. What it's saying is economists have put together a grocery shopping list, and they want to know how much this shopping list basket has cost throughout time. Say your grandpa had paid this whole basket with milk and steak in there for let's say $30. But nowadays we have to pay for $120 for that basket. Then that's an indication for inflation. Okay, just want to make sure that I didn't lose anybody. Would someone, let's see, Brian, what is the indication for shipping cost? Would you tell me what's that?
The Baltic Dry Index.
Perfect, thank you. move on to our trade and stringency data. Here, I would like to introduce you how I clean them. So first, you can see here, the trade data has this interesting combination of countries. Instead of a Euro country, it packed itself into a Europe area. So I looked into their fine prints, see who's in Euro area. And here is their explanation on the countries. Can you all see there's a chart, and they only said advanced economies, and I have to pull out all the European countries from this list and so on. So this is quite different from the lockdown index where the country is individually listed. So how I clean the trade data is, first I go into, I drop the column file I don't need. And then instead of the date being one column and all the dates being the following rows, it has all spread out into lots of columns. So what I did is I used this melt function. Let me play it. Uh-oh. Wait. All right, it's not playing. So I use this melt function. After it's melted, oh, I really want to show you my data. Let's see, trade. After it's melted, okay, you can see here we have a more normal looking data sheet with area being one column, date being its own column, and the export and import index being its own column. That's with the melt function. After that, I need to work on this date format because you can see here it says 2000M01. That is not something that we can process with the formats. So I went in there. So I'm using this list function within Python right here. I create a new date list. This square brackets indicates list, and that's a method to store data. I really like to work with Python lists. It has a lot of good functions that's already built in there, and to me it's really straightforward. So that's what I did. And then I go into this date column, iterate through all of them, go through all of them, and I break them in half from this M. And here I use the indicator. The former part is the year. So I chop them off, and the former part, I put it in this year. The later part, I put it in the month. And in this month, I make categories, and I go through them to see if they fit in any categories. If it falls in Q1, then it will not be shown as 01 anymore. It will be shown as Q1. And then I combine the later part and the former part. Now we have a new date that looks normal. After that, I put this new date back into this list. When the list was finally being added, it looks like this. So finally being added, and then right here, I put it back into this data frame. Data frame is just like a data Excel sheet. So that's how I clean my trade data. And here, for my lockdown data, let's see the place. No, it does not. Okay. Okay, here. First, I keep the columns that I need, which is the location, the date, and stringency index. And as you can see, it looks really organized and normal and everything. But in order to combine with the trade data, which has a really interesting categories, I have to create these new categories. And then what I did is the same trick that I used before. I iterate through all the locations. If it falls into the category, instead of Zimbabwe, it would be show us the category name instead of the location itself. After I did that, And also if the country that's not being mentioned, I will put a null value in there. And finally, I add this new list back into my data frame and create a new column. It's right here. You can see this Afghanistan was not mentioned. It's being null because I want to see if I have the right location and the right area matching. After that, I use the datetime format to make these dates into quarters. I figured that way it's easier to look at. Finally, I come here and drop my area that is null, which is not mentioned in the other data sets. Also, I drop the index that has zeros in it. And here we have it, the clean. And finally, I keep this 3 columns, area, date, and stringency index. And that's our clean data. All right, after all that explanation, finally, I'm gonna show you my visualizations. Here's our stringency index. As you can see, the beginning of 2020, for red being the most severe, the whole world is going through a huge lockdown. Everything's closed. But over time, there's some different severity through countries. Some has more severity, some lift their lockdown policies. And we can see this time series as the stringency index change. And also I call it my Christmas light chart. It just looks festive. Next thing is trade data. The trade data here, the way you look at it is 2010 being our baseline. So whatever is better than 2010 goes up and vice versa. So here, 2011 first quarter, there's 105%. That means it's doing 5% better than 2010. And yes, overall, you can see they're going up and up. We're having more trading, that's undeniable, despite the fact that there's a huge impact in 2008 and 2021. Finally, we're going to combine them and see what their connection is. There. As you can see here, this is the lockdown index. Here. This is the lockdown. Other than the initially impact that I have bring exports down, other than that, there's no severe any affection or connection here. And so is imports. Only the initial part was being impacted. So Nicole, is there any country that you would like to know more about? We can pull their data out. What would you be in? Which country would you be interested in?
That's a very good question. I see all these fun things. Give me one. I see Japan up here, but
yeah, anything, just anything.
Australia. Sure.
All right, that would be our category in advanced economies due to the trade data's categories. Somehow they don't want to discuss Australia's advanced economies. Where is it? Other advanced economies. Here, and that is the, look, here is the trade data, and that's the lockdown. I don't see any connection here. And that brings my first conclusion. There's no positive correlation between lockdown and trading. As you can see here, we're expecting a positive correlation, but the lines here just all over the place. So I want to look into, did lockdown affect the shipping time and shipping costs? Here's my next data set. Baltic Dry Index and the Purchasing Managers Index. And I have a little cleaning video that I made here too. Let's see if I play. Let's see, try to explain. Oh, it does not play. Okay, so you can see here, they have an interesting way of presenting their date too. So I go in there, make a new list, and iterate through the dates and chop them up from the space and the little dash here. The former being the month and the later being the year. And also I set up the categories If the category falls into Q1, it will be represented as Q1 instead of the month itself. And then I combine the new date, new year and new month, put it back in the new list. And then we will have a nice and clean date to work with. Back to my data. So my first Baltic dry index data that indicates shipping is this blue and orange charts. I could not get the data that's before 2017 because I have to pay for it, but average, it falls around 2,200. Anything that's above 2,200 is being too expensive. And you can see here, right after lockdown hit, the shipping price has went up twice as more as the average. That's never seen before the past years. And here, the Purchasing Managers Index is the green and the red line here. The average falls at 50. Anything that's below 50 is no good. So when COVID hit at first, here it had the PMI has fallen below 50, but after that it seems fine. It's doing good. It's not much difference compared to the shipping costs here. So what about the connection between lockdown and shipping? So yeah, I am not going to talk about the shipping time here, the PMI, because it doesn't look like there's any connection. We look into the lockdown and shipping. Oh, I'm sorry. Yeah, here, the lockdown and the shipping apparently doesn't have a connection with the lockdown either. Lockdown didn't affect the shipping cost and shipping time. That brings my second conclusion. There's no positive correlation between them either. So I want to know who caused inflation, because as per data shows, there's inflation. That brings me to my next data set, the CPI, Consumer Price Index. You can see here, this is the baseline 2010. Anything that's higher than 2010 goes up, and vice versa. So you can see here, there's a drastic increase on the steepness compared to the rest 10 years. And so this chart is even more dramatic. You can see this is 6%, as for USA, there's 6% increase. That's compared to the previous year. And then the past year, 2021 has 5% increase. 2020 has 1.5%. That means since COVID started, these three big buckets are the total inflation that we have suffered. That's about 13% in total since COVID happened. That is very drastic compared to the past 10 years. There's really not that much difference. So what I found out that most connected to my data sets that's most connected to the CPI is the shipping cost, Baltic Dry Index. You can see here, when Baltic Dry Index at its high peak, which is like 4,000 something, the CPI went up as well, along with the line. And you can see the correlation chart here. Every 1,000 of Baltic Dry Index increase, it will brings about 5% more on the CPI increase. That is quite drastic, because CPI doesn't just go up and down. So what else do you think would affect CPI? Andrea, can you take a wild guess? What do you think would affect, would cause inflation? Just any guess.
I'm going to say probably stimulus from government. That's what my guess is, because we have
That is a really
money.
good guess. That is a really good guess. And I bet there is some connection, but I was hoping you would say oil price. Yes, because oil price do have a huge connection with CPI too. I look into that since lockdown didn't affect it. So this is the oil price per barrel. With the timeline going up from 2020, so was the CPI. And we can see the correlation here. About every $10 increase on oil per barrel, we will have a 2% of increase on CPI. That is considered pretty drastic too. And believe it or not, the oil increase is because the shipping costs increased too. One of the results that shipping cost has increased. I'm sorry, let me rephrase that. So oil needs to be shipped to the consumers in order for them to purchase. So when shipping price increased, it did affect the oil price too. So they all kind of they're all connected, aren't they? That brings my final conclusion. So COVID, at least for the lockdown part, did not directly affect the inflation, but it did start a butterfly effect. And balls keep rolling, and eventually everything was tumbled into a big inflation circle that we all suffered. And what I learned from this capstone that I thought is very valuable that I'd like to share with you is how easy it is to manipulate data to make it look like the way you want it to present. How zoom in it is, how zoom out it is, what's the baseline year. So next time when you see a shocking chart, just take a closer look. This chart might be just picking cherries. And that concludes my presentation. Thank you for listening. Let me know if there's any questions.
Great job, Ruby. Okay, are there any questions for Ruby?
Makes sense.
Great presentation, Ruby. It was really good. The topic you selected is unique and it covered a wide range of events. Your analysis tells a great story about how the trade was affected during the COVID times and which eventually caused inflation. I like the way you explain the Python list with examples. And I see that you guys are using Panda library to great work.
Thank you.
Dave, did you want to say
Did you say
something?
you have a question?
I always do.
I'm
I always
sorry.
I know you do.
Hi, Dave.
Hi, Ruby. Nice job. It was intriguing to go through all that and see where it was going to end up. So I appreciate the business context of what you were doing. Let me just kind of ask about the working with the data between the things you had to do with Python and the cleaning of the data versus, let's say, the Tableau work. What did you find more challenging and what you had, the most challenging part of what you had to do?
Is definitely combining them.
Okay.
Each data set has its uniqueness. You have to see the mutual in them and then make them in the same way. And finally, you can put them together. That took a lot of time.
Okay.
Thank you
Okay.
for asking.
So how big of a data set was it? Like, was it 1 million data or?
Oh, that's a good question. I didn't keep track, but let's see, what is my biggest data? They're all rather clean because I get this information from International Monetary Fund. They have provided their source. They didn't directly say give you the link, but they say what kind of index they use. So and plus they are more economic related, so they're more being referred. And I think that's why they're usually more clean. And also I have to pay for the more former data or like Baltic data that's more related to economy that I have to pay for. That's what my guess is.
Yeah, I think so. Yeah, it's a very good presentation.
Thank you for asking.
Okay, well, if there are no more questions for Ruby, we will move on to our second presenter, who is Brian. Brian, whenever you're ready.
Ruby, thanks for that presentation. It was very, very enjoyable. So might take a little bit for my screen to pop up. Sometimes moves slowly. So All right, I got a message saying everyone can see it, so that is very, very good news. So good evening. My name is Brian Cutchin, and I have an extensive background in various supply chain management roles from purchasing, order management, and production planning. In each of these roles, I always had a desire to tap into all the data that these companies were creating, and didn't really know how to do that in an effective way until taking the Savvy Coders Data Analytics and Python Bootcamp. So as a child, I enjoyed playing sports. I played every sport imaginable and loved them all. Sports was my life and still is, as I am the best armchair coach out there. So when it came time to pick a topic for my capstone, I decided to base it around sports, and more specifically around do players' salaries impact their team's winning? So I wanted to find out that if a team spent more, did that show up in the win column? So for this project, I chose the MLB. And why the MLB? Unlike other sports leagues, they don't have a salary cap. They only have a luxury tax. So teams are free to spend as much or as little as they desire. And so this creates potentially could create a wider range, a bigger difference from the team paying the most to team paying the least. And we can see this actually currently in the year 2022. The Mets, they pay a player named Max Scherzer $45 million for one player, while the Baltimore Orioles pay their entire team only $35 million combined. So there we see one player making more than the entire team. And then also sports analytics is big in baseball. It has strong roots in the MLB. I don't know if anyone has seen the movie Moneyball, but that is a movie that came out a while ago that is about how analytics became big in baseball. It features around the story of the Oakland Athletics and Billy Beane. And also, we can see this today as in baseball, people have done research in that the most runs are scored in the first inning. And so with this knowledge, teams such as the Tampa Bay Rays have experimented with having an opener. So if you're familiar with baseball, a lot of teams will have a closer who will come in at the end of the game and throw the last inning or two, and is really a really good pitcher that can throw really fast fastballs and has good control over their pitches. But teams now, like the Rays, are starting to use an opener. So the opposite, someone who'll come in maybe the first inning or two to get through the top of a team's lineup. So the ace, the main pitcher, doesn't have to face the top of the lineup as often. So we see here is that there's all this noise. I'm sure many of you that deal with data on a daily basis can understand this. You have all this noise out there, and how do you effectively get through it? So we can just click on some of these and see like the St. Louis Cardinals, that they have kind of our mid-range team. They haven't really had higher than that 6th highest payroll, but they have won championships. They have finished with the best record. However, they have not finished worse than 18th. We can see teams like the Yankees, who have historically had some of the highest payrolls in all of baseball. In fact, they had the highest payroll from 1999 to 2013, and that their winning is pretty good until recently. They've kind of fallen off. We have a team like the Oakland A's, like I said, had basically kind of started this whole idea of sports analytics, that they have fairly low payrolls, yet their winning is kind of all over the place with good seasons and lower seasons. And then we'll have a team like the Kansas City Royals, who historically have very low payrolls, very poor records. However, one outlier was in 2015 when they had the 4th best record and actually won the World Series championship. So this is my data, what I worked with. I got a lot of my data from a sports statistics website called the Baseball Cube. They track everything to do with baseball, from the major leagues to the minor leagues and to college baseball. And they had it in CSV format, so I was able to take that and just save it, and then ran a Python code, which I'll show you next, and I got this format down here, which was a little cleaner than this up here. So my first Python program that I ran, I imported pandas SPD because I wanted to create a data frame from my data, and then I ran it as a loop so that as I was using the data from 1998 to 2021, so for 24 years worth of data, I wouldn't have to keep Xing out of my Python program and running it 24 times. This kind of kept me in my program so that I wasn't wasting as much time. And then I added the year for which I was dealing with the data. And then I took out a few columns, renamed some columns, just dropped some columns that weren't that important. And then had a few equations to put in here to do some basic math. And this third block was actually where I had a lot of difficulties. So looking at my data, I thought it was a number. However, running data type within pandas showed that it was actually an object, so a string of data. So I had to replace some commas and some quotations around the data so that I could get it to be a string and then save it as integer to run my equation to find the payroll above league average. And then from 1998 to 2021, a few teams have actually changed their names or changed it multiple times. So I went ahead and changed them in these yearly data files, just so when I got to the combined file, they'd all already be the same. So we have teams such as the Anaheim Angels, now known as the Los Angeles Angels, have had a few name changes, as well as the Montreal Expos are now the Washington Nationals. And then so I saved this as a combined CSV file. And then I had a little message that told me when it was done, so I know it was saved and I could move on. And then I would even have a message pop up asking if there was anything else left to do. So 23 times I put in Y, so I could run this over and over again. And then once I put in something like no, it would say my task was complete. And then to save a lot of heartache, I have this except error in there so that if in the file I was working, or the folder I was working in, if it could not find my file, if I happen to type incorrect name or something, this message would pop up and ask me if I wanted to continue. So I did all that, and then next I wanted to combine all the data into one file. So I combined them into one using a couple Python things such as import OS, import glob, and import pandas again. So the OS called the operating system so it could find the folder and files that I wanted, and then told it to look for all the files that ended in .csv. And then it so went in and found them, and then I wanted to concatenate them, so stack them on top of each other to create a clean file. And so that's what this did, and then it saved it as complete. So here is a view of CSV file, but this is actually saved as the Excel file. So then I went in and added, just formatted some of the data better, and then within this, on some other sheets, did some simple lookups and stuff. And so overall, this is kind of what our data gets me to. So we can see here that the New York Yankees by far are one of the winningest teams, as well as a team that pays crazy amounts of money. They outspend everyone on average by about $85 million a year. And then behind them, we have teams such as the Red Sox and Dodgers, and then our beloved St. Louis Cardinals are right here, so that we can see that they win more games on average than most teams, while spending about $10 million more per season. And so this first quadrant of teams represents teams that spend less money, which in turn they win less. And then we have teams in the second quadrant up here, like the Detroit Tigers, that win less than most teams while spending more money. And then we have this third quadrant, as I talked about, teams that are winning more while spending more money. And then we have this final quadrant where teams are winning more, but doing it while spending less money. So right here we have, like I said earlier, we have the Kansas City Royals, who have the worst record over these 24 years and have one of the lowest salaries. However, back in 2015, they actually won the World Series championship. While you have teams such as the Yankees, who have won 4 World Series championships between 1998 and last year. But they do it at the cost of spending a lot more money than other teams. So on this next screen, we have just a yearly breakdown of what this looks like from 1998 to 2021. And so you can just see how it changes potentially from year to year, team to team. So in 2001, we actually have the Mariners winning the most games in this set of data, with almost 120 wins. And then their payroll ranking was 11th. But if you look, the Athletics, second most wins while having the second lowest payroll. So we can see this from team to team and year to year. So does anyone know when the St. Louis Cardinals won a World Series championship? What year?
2011.
That's right. 2011 is one of the years they won a World Series championship. So we see here that the Cardinals had the 11th highest payroll while having the 8th best record. So they won a few more games than everyone else and spent a little bit more money. Does anyone know the second time they won a World Series championship?
2006.
That's right. It sounds like we have a Cardinals fan in the house.
You got a Moneyball fan in the house too.
Okay. So we see that the Cardinals won in 2006. And again, they had the 11th highest payroll while having the 13th best record. So after doing this, I thought, oh, maybe anytime the Cardinals have the 11th highest payroll, they win a World Series championship. However, after looking at my data set by running a pivot table in Excel, that is not the case. These were the only 2 times that happened. So if we look in 2003, we actually see the Tigers, who happen to have the least amount of wins in this data set, with only 43 wins. But so they're way down here. And then we have in 2013, we can see that the Yankees spent about $200 million more than the Astros that year. I think that's the biggest difference in payroll for this data set. So the Astros spent about 24 million, while the Yankees spent $229 million roughly. And actually, for these 23 years, the New York Yankees has spent over $4 billion in player salaries. So then here, I created a little graph for payroll efficiency. So yes, we want to see if teams are winning more, if they're spending more, but I also want to look at, are teams being efficient with their payroll? One downside to this, if you're the top team, the highest paying team, and you're winning every year, your efficiency would be naturally 0, just based off payroll rank minus record rank. But we can see here that teams such as the Oakland Athletics and the Tampa Bay Rays, they finish better than what their payroll ranking might suggest, while teams like the Mets and the Cubs fare worse. So they're spending a lot more money and not quite seeing the results. So what does all this show us? It kind of shows us that teams who spend more do win more. So the team with the highest payroll normally finishes in a better position than any other team, while also collecting more wins over this time. And for both of these graphs, there's a pretty strong correlation. The R value is 0.7, so it's pretty strong that teams who are spending more are winning more from 1998 to 2021. So what is next? So for myself, I want to continue this with the NFL and the NBA. So both of those leagues do have a salary cap. So maybe looking at those a salary cap impact a team's performance. Maybe having a salary cap, the players are more evenly distributed, the best players. So one team can't just pay all the best players. And then also adding 2022 to this project and beyond, just kind of keeping up with it, seeing if this trend continues. And then I want to give a shout out to the Savvy Coders team, just for Justin, for getting people plugged in, Ashley for teaching us, taking time out of her schedule, and for Lori for being a huge help. Also to the LETC team, some of y'all got to meet, just for their support and help making this possible. And also my biggest encourager and supporter, my wife Grace, being a huge help over these past 12 weeks, keeping me focused and on track. And then also a bunch of my friends want to see this project since they love sports and baseball. So hopefully we'll show them this. So thank you for your time. And are there any questions?
Great job, great topic. Does anybody have any questions for Brian? I'm sure you do. Come on, Dave.
I've got 1,000, especially as a huge sports fan and unfortunately a Detroit Tigers fan.
Oh, I'm sorry.
So actually my question would be this. So I saw you had to do a lot for pulling in the data when teams change names and things like that. If you worked with a much larger data set, how much more complicated would your Python code have to be to pick up, let's say you went all the way back to the 1890s and went down a level to like the player level and things like that? Would you change your approach to this?
Yes, I would probably have to design it a little differently if there's more variables involved. Like you said, like going back all the way to the 1800s, there's teams that don't exist now, or teams that have changed cities a couple of times. I know that had to be one thing I'd have to do for I know the NBA, a team like the New Orleans Pelicans used to be the New Orleans Hornets, but now you have the Charlotte Hornets, but used to be the Charlotte Bobcats. So yeah, there'd have to be a little more, I guess, cleaning and understanding of the data if there's a lot more changes involved.
I would love to see this with as you change the things like the introduction of the DH and how that impacts salary spend and the wins and just the National League versus American League comparison. It's gonna be fascinating to see.
Yeah,
You could spend years and years on all this.
Yep. And then I actually took a quick look at the current standings and payrolls and the teams that happen to be, because the All-Star break is coming up soon, and most of the teams at the top do have the highest payrolls. I know the Orioles, having the lowest payroll, are making a push for the playoffs, but they are also happen to be in the worst division in baseball, so that might have something to do with it.
And after last night's game, the Cardinals need a new closer.
Oh, so painful. Great job. It was very interesting. Thank you. Okay, if there are no more questions for Brian, we are going to move to our next presenter, Ashley Shutson. Whenever you're ready.
Hi, everyone. Thank you, Brian, for that wonderful presentation. Super interesting. Okay. Can you guys see my screen?
Yes, ma'am.
Okay, awesome. Okay, so let me get adjusted here. So hi, my name is Ashley. Honestly, I wouldn't have thought that I would be in coding or an analytics class, but here I am. And finding out that I had a passion, I wanted to fight for the underdog. Originally, I had studied American Sign Language and psychology, and I wanted to intertwine the two to become a psychologist for the deaf community and kind of bridge the gap between the hearing and the deaf world. But I felt like I needed to go deeper. After I had a friend had a run-in with Family and Children's Services, I realized that the path of fighting for the underdog was not for the deaf community, but for the children who are put in the foster care system and everything that the process does and doesn't entail. I found out that it involves a lot of data. So that's why I'm here, and I've completed a capstone project on this topic. So this is a little bit about me. I am driven to learn tech. I love everything about it, and a little bit personally about me, I love singing and dancing and swimming. So this is kind of an overview of what we're going to go over, how I used Python, my data cycle, my process, all the beautiful data that I'm going to show at the end, and the conclusion of my question. And my question is there a bias spike in foster kids? Do states with higher crime rates tend to have a higher percentage of CPS investigations and kids in foster care? So a couple of questions I started out with were, do caseworkers have any preconceived notions? Do caseworkers have like an overload? Are there certain quotas that need to be met? Do caseworkers have a corrupt mindset, only seeking a financial gain? And are there relationships behind closed doors, such as lawyer to judge or judge to caseworker? And there's thousands of kids being placed in the juvenile system each year, but why is this suddenly a rapidly growing global problem? There's a lot of things that go on that, we can't calculate, such as opinions. There's not really data on that, but what I can figure out is if there's a correlation between crime rates in each state and CPS involvement. So with my data, I was very lucky to find multiple websites to give me very clean data already that I could use for my project. And I found for 2019, each state that had foster care, children entering into foster care, the investigations, and children receiving services. And so I collected all of that data and I entered it into Excel manually. And then I was able to turn that Excel file into a CSV file and pull that into Python. So this is all the information that I got. So, which I just said, and I pulled that into Python. So here is, let's see. This is where I actually do my calculations to find my ratio. So here you can see I've taken the total reported number of crimes and I divide that by the population. And then I also take the total CPS involvement and I divide that by the population and ultimately divide the two outcomes of that and get my final ratio. So I had a lot of null values. There was a couple of states that didn't have certain numbers for investigations or certain numbers for services being received. So I just put not applicable in those slots. And here I was able to get rid of certain columns that I did not need, extra data that I was not going to use. So here I plug it in and I pull it into Tableau. And as you can see, this is the population of each state in 2019. And if you look here, California, Texas, and Florida, the darker states, obviously they have a higher crime rate. If you look closely as we keep going, you can tell that there is a little bit of a pattern in the darker states. So, and these are the states that are receiving services. And here's the foster care, better visualization there. So if you want a better visualization here, California, obviously, just because it has a higher population doesn't necessarily mean that there's going to be more involvement. So here, when I take the ratio and I put that together, that's ultimately going to tell us, you know, how big of a correlation that we actually do have. And so these three states need to get it together. So I wanted to see, you know, if there was a correlation, and here, oh no, there's my graph. I don't know where my graph is. It was such a beautiful graph.
It just popped up down in the bottom, real briefly.
Is there like a, let's see. Oh no. I'm so sorry. Well, we'll just move on. So, and that was the best graph I made too. Anyways, I'll just kind of give you a little like run over verbally about that graph. There is a beautiful trend line that shows the ratio, that there definitely is a clear connection between CPS involvement and the crime rates, which is unfortunate. As you can see here too, you know, whatever is more visually appealing, it all shows the same thing. My references, here are my references that I used, and it's actually very lucky to find very good data. So I ran into a couple problems during this project, you know, that there's so many workers who've taken kids due to false pretenses, you know, due to false allegations, due to, you know, parents arguing out of spite, that kind of stuff. You know, there's no good way to calculate that. So I had to stick to the hard data. And putting this all together, you know, you can usually come up with your own opinion ultimately. You know, it's just a very unfortunate topic, but it's something that someone's going to have to cover, someone's going to have to talk about. And, you know, there are many corrupt workers out there, regardless of hard facts. They still continue with, you know, investigations and don't consider actual safety of the children and of the family, which is another problem. You just, you know, you can't do anything about that. So I had to think about factors that I could, you know, put into a data set and show that there is a correlation, you know, with unfortunate events. In the future, if I were to continue on this project, I would definitely think about, you know, what happens to these kids in foster care, you know, why would a caseworker want to, you know, meet a certain quota instead of thinking about the children, and, you know, kind of like a bigger reasoning behind all of that, and find hard facts just to, prove my ultimate goal, just to show awareness. And I did want to give a shout out to everybody. I loved being a part of the Savvy Coders program. I absolutely love this course and I had a wonderful experience. I was supported by all of my teachers, like Justin and Lori, and Ashley was so awesome. She always helped me if I had any questions, and they encouraged me the whole way. And it was a really awesome experience, and I'm super excited to get a kickstart on my career. So that's all I got. Thanks, guys.
Thanks, Ashley. That was great. Does anybody have any questions for Ashley? Dave.
You're gonna make me do it. Somebody else has got to have some questions.
I've
So-
got a question.
Go, yay, Susan's here. Yes. Go, Susan.
Hi, I'm Susan from Doherty, and I have a question about, you mentioned that there were a lot of null values in the data set that you dealt with.
Yes.
Do you think that those null values had an impact to your findings, and would there have been an alternative approach to dealing with those null values as opposed to like eliminating them from the data set or filling them in with a null value or a 0 or something like that?
Honestly, I don't think that it would have created any significant change. The graph that unfortunately did not come up, there was no obvious outliers. And so it just makes me think that, looking at that trend, that, any certain number that would have been in place of the nulls wouldn't drastically make any difference. I haven't thought about what I would put in place of, but that is a good question. I have to think about for the future.
Okay.
All right, great job. Okay, so if there are no more questions for Ashley, we have, last but never least, we have Evyn. So whenever you're ready, take it away.
Certainly never least, considering you've all sat through 40-minute presentations from me. So let's see, let's make sure we're sharing. Move things out of our way. Mode. All right. So I'm going to do one more thing. Just move that out of the way. And I do want to apologize in advance. I'm just going to move the chat bubble out of the way. So if anyone does make any comments during the presentation, I will, try to address them at the end. Okay. So, hi, my name is Evyn Johnson. I'm a digital marketing manager with a background in theater and communications. So I specialize in branding, social media, CRM management, storytelling, and I have experience with business development training as well as sales and direct marketing training. And as I said, I have a background in theater. So if you see me looking over, I'm checking out my script here because that just keeps me going. So I graduated with a degree in theater and a minor in communications, TV, and film. So my directing background has taught me how to see the bigger picture. I enjoy piecing together data and highlighting the story that data holds. As a digital marketing manager, I think it would be really foolish of me not to recognize that the future of marketing really lies in data analytics. And any business that isn't utilizing digital marketing and data analytics is missing a huge opportunity for growth. I teach digital marketing classes as part of my job, and I encourage the entrepreneurs that go through my classes to engage ethically and responsibly when they're collecting their data and engaging with users on social media. I do try to live with the idea of doing the most good for my community. So as a digital marketing manager, I'm constantly engaging with people on social media. But with all of the studies that are coming out about the negative effects of social media on the user, it made me really start to question if encouraging people to spend more time on social media was really the right thing to do. I began to ask myself, if digital marketing managers are really just the pushers for the world's most addictive drug. which brings me to the topic of my presentation, which is social media detrimental to the user's mental health? So before we get too far into the topic, let's talk about this process. So you know what they say about planning? If you fail to plan, then you're planning on failing. So the scope of this project at first was like really daunting. There are so many facets that I could focus on, and I knew that I needed to get organized. I'm a list maker. I make like a million lists everywhere. Like I'm literally surrounded by lists right now in my office. It just helps me keep organized. So I started by using an easy Scrum template on Monday.com. This isn't an ad for Monday, but I just really enjoy their site. So first, I created an outline to kind of help me figure out what data I wanted to use and how I wanted to use that data, just to help me keep everything, in line, because I knew that I would probably forget a data set or something, and I didn't want to, it takes so long to find the data sets. I would hate to not include something just because I lost it. So then I created the list of all of my tables along with the raw data set that they corresponded to. Just again, so I knew what was what and where I was going to use it at. I gathered data from several different resources. I used data sets from the Pew Research Center. I used 3 sets from them, and then I used other sources like Statistica, Our World in Data, and Keepos, which are just like data digital marketing trend sites. I did use a couple scientific studies, but when I would use those scientific studies, I actually went to their resources page and looked for their data sets so that I would get the raw data and not kind of, as someone mentioned earlier, as Ruby mentioned earlier, it's really easy to skew data. I didn't want any bias in it, so I went and got the raw data first. And then I went through and parsed it. This is actually all of the SQL that I used in the background of there. It's really tiny. I know you can't read it, but I went through and I saved all of that, and I just thought it looked really pretty in the background. So this is kind of what my raw data looked like. I know it's small, but I just wanted to show you kind of the scope of it. It was like a ton of variables and a ton of like ones and zeros that I had to translate into actual, real words. This is another example of what my data looked like. So the first thing I did was I read the survey questions and highlighted the data that I found useful in them. Then I made a list of all the questions I wanted and the corresponding variables. Again, I'm a list maker, and that just made everything so much easier. Then I used Python's expressions, specifically, pandas, to wrangle the data and remove any superfluous data that I didn't necessarily need. And I did this for every data set that I worked with. Once that was completed, I used SQL to parse the data into easy to read format, and I used Excel expressions to convert my tables into percentages. I found it just a little bit easier to work in Excel to convert my percentages versus, the other option I had was to use Pythons. I just found this to be easier because my data sets, once I parsed them down, were much more manageable in Excel. Once all that was complete, I used that to make all the lovely the tables that you'll see in this presentation. I did have a really fun time learning a new expression with my project. One of the data sets I downloaded was in SAV format, and I learned how to convert that data into CVS using PyReadStat and the Pandas data frame. So that was just like a fun little thing that I got to learn in addition to everything else. So let's get started into the actual presentation. So what is social media? I mean, we all use social media, so we know what it is, right? We have photo sharing sites like Instagram, blogging, which would be like Tumblr, or Twitter, which is considered a microblog. Obviously, gaming sites like Discord, social networking like Facebook, Snapchat, YouTube, which would be video sharing, virtual worlds, which is like what metaverse is kind of becoming, and then review sites, which is like Rotten Tomatoes and Yelp. So I created this timeline because I wanted to show that all of this has been happening in a relatively short time. You can see that social media was, that the internet was started in 1991, And the latest data point we have here was going to be the launch of TikTok in 2016. So you can see it's been about 25 years and all of this stuff has happened so rapidly. You can see in this area here, like bam, right after another, all of these sites were being created. So this chart shows the penetration of social media throughout the world. A really interesting fact with this one is that if you see here, the United Arab Emirates, they have 100% penetration. That means 100% of their population uses social media, which I found to be particularly fascinating. I also want you to hold on to that thought because we'll talk about it again a little bit later. This chart is just showing you the percentage of change over time. As you can see, there's been a huge jump from 2012 to 2013 with the amount of social media users. So this is us here. There's 4.623 billion social media users today. Like that's a huge amount of number. I mean, that's a huge amount of the population. And you can see that the growth is actually over time is kind of decreased. That's just because so many people are currently using it that obviously the amount of people that are joining is going to be less. So here are some of the most popular sites for social media. You see these top three, we got Facebook, YouTube, and WhatsApp. These numbers that you see here are in the millions. So that's actually 2.9 billion users on Facebook alone, which is absolutely insane. That's a huge number of a population. Here's the type of sites that the teenagers, this is from one of the Pew Research studies I did, teenagers 13 through 17 really enjoyed using. You can see the top site used by them is Snapchat, and I do know that to be accurate because my 16-year-old cousin told me that I was old because I didn't use Snapchat anymore. So, apparently it's really popular with the teenagers. And this is a site, this is for adults 18 through the highest data set here was 87. And you can see with them, Facebook is the most popular one, followed by YouTube, and Snapchat only has a 28% user rate. And the average person spends about 2.37 hours a day on social media. You can see in 2020 that number was a little bit higher, presumably because of the pandemic and we were kind of all online. So, there's been a little bit of a decrease since then. So over the past 12 months, 326 million users have joined social media since last year. So if we divide that by the number of minutes of the year, that's roughly 620 people per minute. So about 10 people per second are joining social media, which is like an insane rate of growth. And you can see this prediction line that it's predicted that by the year 2025, there will be 6.5 billion users. And another really interesting fact that I found was like how frequently we're using social media. So you can see here that almost everyone is almost all of the teens 13 through 17 are using social media either almost constantly or several times a day, with the exceptions of 14-year-olds who use it less often. 50% of them use it less often. So I guess 14-year-olds are over social media. I don't know what that means about the future, but I just found that to be an interesting outlier. And the same thing goes with people 18 through 70. You can see that again, several times a day and almost constantly is the thing that people pick for how often they use social media. For reasons that people use social media, the number one reason was to stay up to date on news, with the very bottom reason being to promote charities. So social media and mental health. What we're going to focus on today is 5 main areas. We're going to talk about anxiety, depression, addiction, comparisonitis, and anger. So what is anxiety? Anxiety disorders arise in several forms, including phobias of social media, obsessive compulsive disorders, PTSD, or just generalized anxiety. And if you see here, this is a little chart that we're going to take a closer look at on the next slide. Oh, I'm sorry, I pressed the wrong button. There we go. So you can see on this chart, I'm just going to go ahead and go back to the beginning and play it, so it'll be running while I'm going. You can see that over time, as the years go on, that people have been getting steadily more anxious. And remember I told you there was 100% user rate in the United Arab Emirates. If you look over here in this region now, you can see that this is probably one of the most anxious regions in the world. Now, it is important to note that this is probably not exclusively because of social media. Obviously, there are other factors as to why this area would be really anxious. But I just found it to be an interesting comparison. However, I do want to note that correlation does not equal causation. So again, with depression, a depression causes feelings of sadness or loss of interest in activities that you once enjoyed. And again, with this chart, which is very similar to our anxiety chart, you can see that over time, the world is becoming a little bit more depressed as we go. Now, again, correlation does not equal causation. There are other factors, but it is just something that I wanted to know. So what is addiction? According to the Addiction Center, social media social media addiction is a behavioral addiction that's defined by being overly concerned with social media, driven to uncontrollable urges to log on or use social media, and devoting so much time and effort to social media that it impairs your important life areas. So addictive social media use can look so very much like people who are addicted to drugs and alcohol. Because it has very much like the same reactions, like you use everything, or you would drop everything to be on social media. So, like I said earlier, there's 4.65 billion people in the world that use social media. That's 58% of the world population. So 7% of social media users suffer from addiction. That's roughly 325,500,000 people that suffer from this condition. Globally, the population is about 7.9 billion people. So roughly 4% of the world population meets the criteria for social media addiction. Now, those are a lot of like numbers. So to put that in a little bit of perspective for you, the number of people who suffer from social media addiction, that's roughly the population of the United States. And I said 4% of people suffer from addiction. Only 2% of people suffer from addiction to drug and alcohol. So back to what I said at the very beginning, like social media is probably the world's most addictive drug. Why is it addictive? So the dopamine-inducing environments like social networking sites provide the same brain activity that's caused by gambling and recreational drugs. So when you get a notification, the neurons in your brain like go off. They're like, oh man, I like that. You get really excited. And it sends a message to your brain that says, this is good, we want more of that. So therefore the brain receives a reward and it associates that reward with whatever action just happened. And that action was getting a notification. So another reason that it is really addictive is because people like to talk about themselves. The reward center of your brain goes off the most when you talk about yourself. So in the non-virtual world, we tend to talk about ourselves between 30 to 40% of the time. But on social media, because you're talking about your accomplishments or anything you might have done or seen, or maybe posting a new flower that's in your garden, you talk about yourself a staggering 80% of the time. So you can see here from this chart, they ask people, what are the reasons that you post? And one of the highest reasons for people to post is either to post updates about what you're doing or post selfies. Then we're going to talk about comparisonitis, aka keeping up with the Kardashian syndrome. The average person has about 6,000 thoughts per day. So 10% of those thoughts are involved comparing yourself to someone else or something else. Now, so pause. I also wanted to note that, again, there are other factors that leads to people suffering from comparisonitis. It is 100% possible to use social media and not have this kind of syndrome happen to you. So constantly checking social media full of images of parties and concerts really it's not super helpful for people in terms of like comparing themselves to other people. Anger in social media, I found this one to be particularly interesting. So online networking encourages us to be more angry over time. That's because the angrier you are online, the more likes and interactions you're going to get. And as we talked about earlier, the brain likes those likes and interactions. So expressing outrage online actually makes your brain happier. So it's kind of encouraging us to be a little bit angrier as a society. If you can see it from these charts, 26% of people say they frequently encounter things that make them angry online. Here. And you can see, oh, sorry, I want to go back one more time. You can see that 91% of people say that they feel angry when they use social media. So this is just a survey of some of the negative experiences that people see online. And you can see that 32% of people say that they frequently see information that they find to be misleading. Here's some of the other negative experiences that teenagers 13 through 17 have experienced online. You can see that red is females, and there's a higher percent of this stuff happening to females than males. You know, this is 13 through 17-year-olds who are called an offensive name online. So that's almost 40% of them. But I also want you to note this 42% here of teenagers that said they haven't experienced any of this. So that leads me to my next point of saying, it's not all bad. If you look at this chart that I created, I color coded it so that all of this like fun, bright colors here are things that people experience online that are positive. Whereas this red part here is like what people experience that's negative. You can see that almost 81% of people say they feel more connected with what's going on in their friends' lives with social media. And only 26% of people say they feel worse about their own lives. And you can see that there's a higher percent of people that say they feel amused online versus the people that say they feel angry when they're online. You can also see here that 67% of people say that they feel that social media has more of a positive impact on society than the 33% of people that say they feel it has a negative impact on it. So to answer the question, is social media detrimental to the user's mental health? Well, that's kind of a tough question because there is an undeniable association between excessive social media use and negative mental health and low self-esteem. However, no one can definitely say that social media is bad for your mental health. Is it addicting? I mean, yes, absolutely. We've proven that it is addicting. However, if you know how to kind of limit yourself, I would say that you do have a chance of not being addicted to it as well. It kind of leads me to the idea of, is sugar bad? Is alcohol bad? I mean, in excess, yes, but if you treat it like any other vice and use it responsibly, then social media is perfectly fine for use. Some other things that I wanted to consider was, I wanted to talk about how businesses can use social media to engage with clients responsibly. I also wanted to talk about if social media was actually causing poor in-person communication, and then present advice on how to protect your well-being. But again, we wanted to kind of keep it down to 20 minutes, so I did not include any of that. Before I conclude, I do just want to thank everyone in the class who's really just been super supportive throughout this whole process, especially Ashley, or Teacher Ashley, as we refer to her, because she's been super helpful and always willing to help us at any time of night or day or whatever, even when she moved across country. So I found that, you know, it was really nice. I also wanted to do a shout out to Ashley, Ruby, Brian, and Luke, who made this class absolutely wonderful. You know, keeping us laughing while we were working and learning all these intense things. Also, thanks to the entire Savvy team, especially Justin for taking all of my questions, and Lori for all of her help with my resume and dealing with me sending her 9 million different versions of my resume. And thanks again to the entire class, especially for sitting through 40-minute presentations on social media from me and encouraging me to keep it simple.
Great job. I want to, first of all, I know there will maybe questions there, but I want to give a shout out to Evyn because she had so much good data, so many great charts. And at the end of our session last night, I said, you're at like almost 40 minutes. So you've got to pare that down. And I know she was a little disappointed and I felt that, but she worked last night to pare her presentation down to, you know, the things that she thought were impactful and the things that really kind of stood out in this topic. So great job. Does anybody have any questions for Evyn?
Yeah, I've got a question. You use both SQL and Python in your analysis. I was wondering if you had a preference or why you chose one over the other at a different time.
As Chuck Severance, who taught us our Python class, said, I chose to teach you SQL last because I knew once you do it, you would never want to use Python again. And I do like Python. I find it to be kind of like a puzzle. But obviously SQL it has my heart just because of the simplicity of it. And as a marketer, I use it pretty frequently, especially transferring data from CRM systems.
Okay. Well, if there are no more questions for anybody, that concludes demo day for the newly minted data analytics and Python graduates. So great job, everyone. It was the topics were interesting and you all did such a great job. Such a great job. And thank you all for our client partners for being here and spending time with us to see the presentations. We hope to hear from all of you soon. So I'll give back do you want to say something, Evyn? Or are you just waving? You're just waving at everybody. Okay. So I'm going to give you back the rest of your evening. I hope that you have enjoyed your time here. And if you have any questions about any of the graduates or you want more information, just don't hesitate to reach out to me. All right. All right. Thank you all. I have to run
Thank
to
you
the
very
next
much.
orientation. So I'm going to shut this down.
Thanks, everybody.
See you
Nice
all
job.
soon. Thanks,
job,
Dave.
everybody.
Everybody
It's
for
really good.
coming.
Okay. Well, Dave.